8 minutes is entitled Bones, Aren't They Amazing? Welcome, Sharon.
Thank you. Thank you very much. Good morning, everyone. Welcome to my yoga studio in my basement where I virtually teach yoga for osteoporosis exclusively online. And about 3 years ago, I took a certification course from a doctor named Lauren Fishman, and I've spoken about him before in another speech. He is a physiocyatrist that has a clinic in New York who specializes in working with people with all kinds of spinal issues, and osteoporosis being one of them. So I started teaching women, mostly women, men would be nice to have, but women who have been diagnosed with osteoporosis. And what is osteoporosis? It just means porous bones. And as I've been teaching people how to build their bone density, I started needing to understand bones itself. And so the past 3 years, I've read articles, I've read books, I've seen websites on osteoporosis. And a couple of months ago, I came across this article in my research that this bone-derived hormone called osteocalcin had a link to the stress response. And I thought, oh, that's interesting. So I started reading about it, and what I found was that there's going to be a sea change in how we see the stress response. Bottom line, that's kind of what it is. But I want to go back and explain what I've explained before in an earlier speech about how bones are made, because it has to do with the osteocalcin hormone. So when we're born until the time women in 25, men 30, our bones are being calcified and built upon to where they are when we're adults, so that we can walk, we can sit. It protects our organs from when we're hit or when we're falling or whatever. But it does more than that. And so let's go back to how they're made. So when we're born until 25, we have this hormone that is made in our adrenaline glands that cause these osteoblasts, these cells that lay down bone matrix. And it's kind of like if you had a wall that was thin and you wanted to thicken it up, you'd put plaster on it, and you keep putting plaster, making it thicker and thicker. That's what these osteoblasts do. And they get a lot. We're building a lot of bone up until 25, 30. And then at 30 years old, that hormone is still secreting, but it not produced as much, so we don't produce as much bone. And yet there's this other cell called osteoclast that are the sweepers off of the old bone. Just like our hair falls out and our skin sloughs off, every organ in our body sloughs off old cells. And bone are no different. But there's kind of like a mathematical equation here, is that at 30 years old, the production of the making of the bone slows down, but the sweeping of the bone, of the old bone, does not slow down. It's the same amount. So if you don't have a genetic propensity for thick bones or other reasons, and you have a genetic makeup of thin bones, ultimately, if you don't keep exercising and doing things and eating right, your bones are going to become porous and get osteoporosis, which the medical society calls it a disease. But after thinking about it, it's a condition. It's preventable and it's reversible in many cases. And there's always exceptions to the rules. So what these researchers found is this hormone called osteocalcin that is produced by the making, as the osteoblasts lay down and make their cell matrix, they secrete into the blood system osteocalcin. And the researchers found that it really did nothing for the bone density. It was secreted into the blood system, and it actually has physiological functions in our body, including memory retention, capacity for exercise, testosterone production, and insulin secretion. There's a lot more, and I'm going to do a speech on those things and how it's affected in the body from this osteocalcin. But as they were doing this research, trying to find out what osteocalcin did, they took a group of mice, and I apologize to anybody who has issues with animal treatment on experiments on animals, because this is what they did. Just putting it out there. So they took these mice and they changed their DNA or so that they couldn't secrete, they couldn't make the osteocalcin. And then they had a control group that was fine. And they stressed them out. They did different stress things to them. And the mice that could not produce the osteocalcin they couldn't get a stress response from them. I mean, they would do horrible things to them. And the mice just didn't get stressed out. And yet they went to the control group and did the same thing, and it stressed the mice out. So they got the reaction they thought they were going to get. So they further looked into it, and they found that this is really interesting, and this is going to be a sea change in how we look at the stress response. It's just so amazing. They found that when we get stressed, the osteocalcin spikes in our blood system and lowers the parasympathetic nervous system to allow the amygdala to start producing adrenaline, which then starts the cascading effect of the stress response, which is totally backwards now of what we think it is. Pretty amazing. I don't know about you, but that just stunned me. So this has caused a huge fight in the endocrinology world, because the researchers saying that the skeletal system is not separate from the endocrinology system, that the skeletal system is actually part of the endocrinology system, which if anybody follows that kind of stuff, that is like earth-shattering news. So it'll be interesting to follow this study and the researches that goes on like this for the many years to come. But as I'm beginning to learn about things like osteocalcin and how what the bones do for us, I'm just totally amazed, and I wanted to share this with you, and I hope that you enjoyed it. And I look forward to coming back and sharing more about our amazing bones. Thank you.
Thank you, Sharon. Excellent. Appreciate all of your knowledge. And again, thanks for not firing me. Our next speaker, Scotty Eggleston. Scotty, it is Scotty. Is that correct? Do you go by?
It's either or, John.
It's either or, I know. And now your email address is scotty.eggleston. Am I correct?
That's correct. Yeah.
Okay, so we need to correct that. I don't think we got our communication